So I'm John Melbye, the Managing Director of ASCM Twin Cities, and we are proud to have with us today Vivek Saxena from FactoryTwin, and we are going to talk about a bunch of things, but the concept of the factory twin, the digital twin, has been around for a while. And for those of us that are, kind of have trouble imagining this thing that we've never heard of or seen before, it's kind of daunting. But today we're going to hear from Vivek about S&OP and how to make S&OP a little bit easier, how we can use AI to augment our S&OP processes. And ASCM Twin Cities is your connection, your community for supply chain, and we're adding in some AI stuff and trying to, again, continue to add value for our members and community. So with that, FYI, we are recording. We will try and make this available on the Twin Cities website as we get it kind of organized and cut down into what it needs to be. But with that, Vivek, I would like to turn it over to you and take us away, please. Give a quick introduction to yourself and then knock our socks off.
Thank you, John. Good morning, all. Thanks for taking the time. As John mentioned, we are a factory digital twin, factory intelligence platform. And S&OP is one of the various things that people need factory intelligence for. So we're going to introduce to you the S&OP module in FactoryTwin. The idea is not just to talk about concept and theory, but actually get into the nitty-gritty today and see, how you actually use data to make your S&OP process more robust, more repeatable, which provides a single sheet of music that all functions supporting production can play from. And as John mentioned, digital twins have been around for a while, and so has S&OP. In sales and operations planning, everyone you talk to who has been through ASCM classes or been a professional in industry knows a very critical, one of the very critical processes to manage shops in the long run, right? Before you get into day-to-day scheduling. A lot of problems can be solved by looking ahead through sales and operations planning, aligning supply and demand, your resource constraints, your supplier risks. But how do you make it easy to use, practical, something that any company can use without having to spend a lot of resources in getting ready for the meeting itself, as an example. So we'll go into that. Just to remind people that we are actually based in Hopkins, Minnesota. And as John says, Hopkins skipping away from most of you. So feel free to come to our website, contact us, and if there's any questions, follow up, please do so. So to start with, just some generalities at the top level. Customers that use sales and operations planning efficiently are generally getting double-digit improvement in all measurable KPIs that matter. And in a shop, they're always on-time delivery, revenue, profitability, and cash flow. And we have customers that have shown these numbers. These are not just theoretical numbers. And incidentally, if you go to MXT, Digital Manufacturing website in Chicago, or Smart Manufacturing in UCLA, people who are using digitalization successfully are seeing these kind of benefits if they haven't used factory intelligence or data before. There's a little QR code here. The only reason I put it, if you wanted to make these numbers real, think about what people feel when they see these kind of numbers. So we have one of our customers, they agreed to do a very extensive interview over a half-a-day process, and you can see how different functions feel about having a robust sales and operations planning. And this is some of the data from hidden cost of poor planning. You're all aware of it. I mean, I would like to highlight this ASCM study itself that shows a WIP of 20 to 50%, which is very consistent with the previous slide when I talked about 50% cash flow improvement by doing proper S&OP. So these are big numbers. And I would also add, having spent 30 years or so in manufacturing, that if you don't take care of long-term planning, if you don't take care of early alerts on resource constraints or supplier risks, no matter how good your scheduling is on a day-to-day basis, it's not going to help, right? Because you cannot react to things as quickly. So S&OP is all about digital planning, looking at problems before they hit you and become more proactive. So isn't that what everyone wants? Going from reactive mode to proactive mode. So let's dive into it. And why is it that if that's such a wonderful thing, people don't use S&OP as robustly and as commonly as possible? I mean, most companies we work with would have heard of it, maybe use occasionally. They don't have confidence in your process itself, and then how long it takes to collect the data, which is sitting in various resources. So as you can tell, many of these bullets will resonate with you if you have attempted to do S&OP with a monthly cadence, which is how it is required to do. I'm going to go over a couple more slides and then jump straight into a demo of how sales and operation planning is done using FactoryTwin. So one of the first things we do in FactoryTwin is integrate all sources of data. So your data sources can be PDF files, Word documents, IT systems like your ERP, MES. Doesn't matter what ERP system you have or what MES system you have. You have some basic data which resides there. And if you have standard processes to collect and store, and you have some confidence, you can say, okay, I like what we have in the data, but most people don't. So one of the things we do is after we integrate all sources of data, we also run data diagnostics and cleansing, and this is semi-automated as well. So we connect all sources of data, including these are relational databases, maybe MT Connect, machine monitoring system, which is your OT. You have Excel sheets. Everybody loves Excel sheets. The problem is other people don't trust your Excel sheets, or maybe everybody has a different version of their source of truth. So what we do is we integrate all those sources of data, including tribal knowledge. And how do we know what tribal knowledge is required to execute S&OP? So we've done a lot of research. We started FactoryTwin in 2017, so it's almost 10 years. And through some National Science Foundation funded grants, we are able to actually estimate before we start any work the number of input variables or the data which is minimum and sufficient to actually solve a business problem like sales and operations planning. And so things which are not existent in Excel sheets, OT, IT, and other sources of data, we know it resides in people's heads. And a good example could be that you're a machine shop and you have 10 machinists on the second shift, but only one can do the changeover, right? The setup is critical for complex parts. And if you don't have that changeover capability, then your second shift is not going to run a new part. And that's why people get surprised when they come the next day and they see that part that was supposed to go on a machine didn't go. Similarly, you may have ability for multiple operators that can run multiple machines. So there are lots of tribal knowledge that people have, which is not captured in any factory database. So we are able to interview the subject matter experts to capture all of this, templatize it, and create a single source of or complete source of information, run the diagnostics on it, check for data gaps and consistencies, and then the front end is automated and S&OP becomes operation. So it's simple 4 or 5 steps. This can take 3 to 4 weeks to get to the point of actually checking the diagnostics of all the data that we've got from all these sources I just mentioned. So once you're there, we do the data integrity checks. We do 470 different checks that check for unrecorded variables, because you may have perhaps machine variables recorded, operation time, setup time, but maybe not manual times, deburr times, for example. You may have incomplete fields. You may have outliers because people fat fingered something in the ERP system. There may be illogical relationships, like it's not very uncommon for us to go and look at ERP data and find that the PO placement date was after the due date. Or same thing from your customer, your sales order line item coming to you has a placement date which is after your due date, or the quantity is not mentioned because people forgot to type it in. So we check all those things and help you build confidence in data. And once you have confidence in data, you can run your S&OP process much more in a trustworthy manner. And this is S&OP process that you're all aware of, right? So it's a monthly cadence. You start the first week by doing some demand planning, looking at where you have lumpiness, which customer is maybe reducing demand, what is ramping up, why is it that you have one customer just placing one purchase order for a part which you think is needed recurring manner. So this gives actions to sales and marketing teams to look at how to look at the customer demand signal and what needs to be converted into forecast, from forecast to firm purchase orders, what action needs to be taken. So it's all about demand planning. It also includes NPI. So engineering is involved here also for new product introduction. And in most companies, NPI kind of gets forgotten because it's not properly sometimes introduced or documented. And so what is the first article there? Oh, shoot, that was last month. And the production is coming up, production date is coming up. So to bring visibility, all that's what you do in week one. Understanding demand signal in its entirety. Firm purchase orders, forecast, new product introduction, future campaigns, all that is in demand planning. Week two is about, given that demand signal, what are the risks? Both internal risks and external risks, right? Internal risk would be, do I have shop resource constraints for machines or operators 3 months down the road, 3 years down the road? And how do I handle that? And what are the supplier risks? Maybe I have a supplier whose spend is going to triple in the next month or next year, but their performance has been poor from quality and on-time delivery perspective. So those are the risks I need to identify and see if I have alternate suppliers to handle that kind of those components that I need to buy. So week two is all about understanding risks from supply side, whether it's coming from your shop or from your suppliers, and how to mitigate that. And that usually can go into week three because it's a pretty extensive exercise. You can spend maybe a couple of hours every week, so maybe 3 to 4 hours to get to completion of that step. Now, in reality, if you did it in a standard manner, it might take you weeks to even do any of these activities. And I'll show you how using this factory intelligence platform, S&OP can be done by push button for all of these information that we are looking for. And then you have inventory risk. You are looking at where we are, what is my bucketing of inventory, what is aging, what is active versus inactive, and that's what allows you to be in a position where you have what you need when you need it, and you don't have excess or shortage. And finally, financial projection to reconcile all the decisions that come out of this. So this is kind of a standard at a very high level S&OP process. The way we handle it in FactoryTwin is the tool mimics the weeks, as you can see on the right. So week one is about demand planning. Week two is about resources internally, et cetera, et cetera. You can click on those buttons and get all the information you need. No need to prepare for information, no need to download information, convert in an Excel sheet, PowerPoint, pictures, plotting, Power BI, none of that. It's all available to you at your fingertips. So let me now jump to actual demo. So our Factory Digital Twin Factory Intelligence platform has basically 6 modules. And today I'm just going to talk about the planning module, which is S&OP. I will also talk about a little bit about AI after that, but let's first just talk about S&OP module in FactoryTwin. So I'm going to get out of this and go to the actual software. So here we are. So essentially, like I was showing you earlier, here are the various modules. Once they get installed in your factory, all that integration of various sources of data has already occurred, and the front end has been activated and validated. Data has been diagnosed and cleansed. And now we're going to launch our S&OPs. The first week of the month, I'm going to start with my demand planning. I go inside and I see for this company, there are 2 states where they exist, in Illinois and in Minnesota. And in Minnesota, they have 2 factories, in Minneapolis and St. Cloud. So let's see what's going on in that factory today. And by the way, in all this data, this is a mock-up data. It's not any customer data, and it actually goes back to 2025. So you have to assume that you are like mid-August in 2025. And so everything is looking ahead from August 2025, as you can see here. So as you go inside, first thing is demand planning. So I click on demand planning, and this is the page I get. And it tells me what is my total demand in the time horizon we are considering. So typically, let's say in this case, it's 18 months looking out. And it tells you what is my aggregate demand in terms of firm purchase orders, in terms of overdue, and in terms of forecast. And I can actually go in and toggle between value and quantity. So now I have dollars, and I can say how much is in purchase or firm, how much is overdue, and how much is in forecast. This forecast may come from your ERP system. It may come from an Excel sheet outside. It may come from a different CRM system. If you have Salesforce.com or HubSpot and you have some kind of a forecast loaded there, we can integrate with that. And so you got everything in one place. And then you can also see the monthly distribution of that firm purchase order, overdue, and forecast. In this case, you can see this shop is roughly looks like $4 million a month type shop. You've got a bunch of overdue in the very first month that you need to handle. So it gives you month by month. Now you can start slicing and dicing and say, okay, this is my demand. How is it by part? Can I look at it by customer? My most important customer is, let's say, GE. So I'm going to go to that customer and see what is their demand looking like today. It looks like you have only one part number on order from them, and this tells you when that part number is due, what is the value. This immediately raises concern in my head. Why is it such a lumpy demand? Why is there so much in December? Is it just a placeholder? Is there demand going to be earlier? So I'm going to have to talk to that customer and figure out what it is. So you can look at all your demand, slices, dice it any way you want, line item, order type. So this is all your demand, but how much is forecast firm orders, and any way you want to slice and dice the demand. So then you can look at a part number level even. So let's say I was interested in a part family first, and I've got these are the different kinds of part families. Let's say blade part family is what I have. It tells me for blades, I have orders from, it feels like there are 3 types of orders. Let's see what customers that these orders are coming from. And it tells you what those customers are. And then you can select the customer. You can say select none. Let's just look at turn off Apex. No. So the idea is that it's a very, any way you can slice and dice the data, get into this stuff is how you look at demand. I'm going to keep moving forward because there's a bunch of things to do. So once you select blade, it also tells you what is your overdue, what customer it is, what is the value. At the bottom, you also have the NPI demand, which actually forces you to put your first article date if you forgot. So it will show you where you have a first article coming up. And this can be done in a manner by talking to customers on how do you decide what parts need first article. But the easiest is the software does a front sweep, looks at all the line items in the firm purchase orders and looks at part number that you haven't done in the past. It does a backward sweep and identifies those parts as those that may require first article. Okay. So this is all about demand planning. In 4 or 5 slides, you have all the information you need to run the first week's demand planning. Then you go to week 2 and you say, well, what is my resource constraint internal to my shop? And first thing it plots on the y-axis all your resources. These are labor resources as well as machining resources or stations, and you have time. And every time there's a red, that is where the potential bottleneck. And the way it's calculated is, standard utilization calculation, which also includes OEE or OLE, which is calculated by talking to you on machine availability, downtime, etc. And so it's all accounted for. And then you can go in and say, okay, I look at it, right? And I'm in week 2 and I see a bunch of constraints coming up next year. So I'm in August of 2025. And there are some constraints here, but those can be handled 116% utilization, but before and after there is some capacity. I might be able to level load it, handle that. But when I come to next year, I got a lot of constraint. How do I handle that? So I start with the one which is most constrained, which is, let's say in this case, EDM labor in Minneapolis. And I want to understand what is causing it. And so what customer is causing it, what part number is causing it. And by the way, the table below tells you the average utilization, whereas this was month by month, right? So you go to operator utilization, EDM labor, and it tells you by part numbers what is consuming that resource in that month. So if I'm looking at the month of May, I see the part number CFCK is really the culprit when it comes to getting the utilization about 150%. So can I talk to the customer for that part to maybe pull that demand in. That's one option. The other is maybe I can outsource that EDM process for just that part, or maybe there are other strategies I can handle, right? Because this is about constraint in labor, EDM labor. So how do I handle it? So I can show you right now how easy it is in FactoryTwin to go do it. You go to the baseline, you say, I'm going to create a new scenario, and I'm going to add a few changes. And here are the buttons. These are the, about 20 or so buttons that allow you to make those strategies. You can make changes to line items. So for example, if you're able to work with your customer to change the due date or quantity of a part which was causing a bottleneck, you can modify that line item to run that experiment before you go to the customer. You can add operators, you can cross-train operators, you can schedule time off, you can add operators, schedule downtime of machine, modify efficiency of machine, outsource processes. Similarly, you can modify standard times if you think you have continuous improvement activity that can reduce setup time somewhere, so that can be accounted for here. And then you can modify shift structure by adding overtime or running a different shift. So these are all the options. So like we just saw that the EDM labor was a bottleneck in next year. So I know, and this is where the part comes in, that no matter how good AI, you always need human intuition. So as a person who's doing this planning, I know that EDM machine can be run 3 shifts, but I only am running 2 shifts. I have other operators doing third shift activities. So maybe I can cross-train some of those to run the third shift. That will definitely increase my capacity by 1/3. So I go into adjust skill matrix, and I know, for example, that it's the finish labor where I can have people in third shift that I'm running that can be cross-trained. So I go in there and I look at the people and I say, all right, but let's see if this person has, or they are in third shift. And I've talked to the supervisor, they think she's trainable. So I'm going to go in and is interested in training. So I'm going to go in and give her, I'm going to run this experiment first before I start to execute this strategy. I will train her in EDM, and let's say it's going to take 2 months to train her. So I'm going to go into October and give her 2 months to train, and I say accept that change. So I did accept the change. Then I'm going to add another change because I have 2 EDM machines, so probably another operator cross-train would be a good idea. And I know this finished labor is running third shift, so somebody from that can be trained. So let's see, this person is also third shift, so I can train them in EDM as well. So here we go. I want to make sure that they also learn the setup skills, and then they will be available with this skill, let's say in October as well, 2 months of training, which is good because I'm in October 2025. I'm trying to handle bottlenecks which are coming next year. And I'm starting this training program now. Now I saw that there were parts that were causing this bottleneck, and the part which we saw, that CFCK part, was the one which is causing most of this. So maybe I can also think about outsourcing that part. So I go in here and I say I'm going to outsource EDM, and I'm going to only outsource EDM, and not all the parts, only the part which we know was a problem, which was this part, CFCK. So I go that and I accept that as a change. Go next, then it asks me who's the new supplier. Let's call new supplier X. And let's say the system lead time to do this is, let's say, 5 days. And let's say it costs $1,000 to do one part, just to make it up. I go to next and I'm going to outsource. Remember, that was in May of next year. So I just need to go to that month, May of next year, 26, and end of April to, I go here, and end of 26, and let's say end of August. I'm going to outsource this process. Okay, and so that has been added. So you can see the 3 changes you made. You can make 20 changes because you saw all the buttons and how easy it is to use any of those strategies: running overtime, third shift, outsourcing process, adding people, adding machines, etc. And then I'm going to save this and see how quick it is. So this mock-up factory, as you saw, has 3 sites, has hundreds of part numbers, dozens of suppliers, dozens of customers, and I'm going to run this scenario in a matter of seconds. So I'm going to call this scenario, let me call it VS scenario, whatever you want to call it. And this is 2 cross-trained operators in 3rd shift, and we have plus some outsourcing of CFCK part, just to have a record of what I'm trying to do here. And I'm going to run this simulation now. So the entire factory starts with the snapshot of what part is at what machine, what POs are coming, what parts are due to the customer, and it changes those parameters and is going to run this scenario, and it's finished running. So if you go into scenarios, that scenario will appear, VS scenario, as you see right here. So I'm going to compare this scenario with the baseline to see whether I achieved what I intended to achieve. So I go into baseline and I go into VS scenario and I say compare the 2 scenarios. I should be able to see both the cost impact of that as well as whether it improved what I wanted to improve. So on the left is the baseline, on the right is the new scenario. And when I look at the 18-month cost, no changes to CapEx because I didn't buy a machine. I could have bought a machine because there was an option. There was no changes in labor hours because I didn't hire anybody extra. I just cross-trained them. So same. Overtime hours, I didn't run an overtime shift either. The only thing that changed is that my outsourced cost went up from 6 million to 6.3 million for 18 months. So you paid 300,000 extra to get that part outsourced, and you just cross-trained the people. So let's see if we achieved the reduction in the problem with bottleneck. So you can see baseline to this, all these bottlenecks in the early part have disappeared. And the value of the bottleneck, which used to be 190% and 189%, has gone down tremendously. So this is how you can run various scenarios. Very easy to run. And coming back to the S&OP process, I was in week 2 of Shop C's resource. So we looked through resources, how we can mitigate the bottleneck. So now I know right now I can generate a list of action. I need to cross-train some people. I need to prepare a temporary vendor assist to outsource that CFCK part in the month of May. And you can come up with maybe I want to run overtime in the future. All those things can be built together. And since I didn't go over some of those, let me just show you how easy it is to use any of those changes in the system. So for example, if I wanted to modify shift structure by adding overtime, so I just go in there, Minneapolis, shift 1. Let's say I wanted to add overtime to shift 1. This is running Monday through Friday. I can go down and just add the shift. I'm adding first shift, and I can say what time to start, what time to end, what day to start, what day to end, and that becomes easy to use. Similarly, if I wanted to schedule time of an operator, schedule downtime for the station, downtime for a station, it's all done in a drop-down manner. It's automated, easy to use. So I'm going to go back. So that's some of the activity which is happening in second week, looking into shop resource risks upfront and mitigating them, right? So once you have done that over time, your actions will, from cross-training to outsourcing to buying machines to hiring people, et cetera, can come in, running overtime, et cetera. And then once you have solved this, day-to-day stuff scheduling will be a lot easier. You have already handled the big problems up front. Then you go to week 2, what are my supplier risks? And now you start with a supplier live scorecard, and it tells you on-time delivery versus average days late. And each bubble size is telling you how many orders you have with them in the last 12 months or in the last 6 months or the last, you trust the data from the last 6 months more, here it is. You can look at it at a supplier level, but you can also look at it at a part level. What is my performance for a given part historically from those suppliers? And you can see their average time late, average days late, and on-time delivery percent. And then you can start looking at the other supplier risks. So for example, so this is historic supplier performance. You can pick a supplier and say, I don't want all of them, unselect all. I want to just look at one supplier, or maybe I want to go with part, pick my part and see who my suppliers are. There's 3 suppliers for that part. I'm going to select them all, see their performance on time delivery. So you can see their on-time delivery. You can see their average days late at the same time. Then here comes the big one, because Part of the reason suppliers don't deliver is also with the customer, that they're not placing POs on time. So one of the things the software does, it constantly checks what is in the system lead time for procuring a part versus what is demonstrated lead time. So as you go down for each part, who's the supplier, what is the number of orders with them, and every time you see a red bubble with something in it, the number in it, that means your demonstrated lead time is longer than what's in the system. If it's blue and negative, it says it's shorter. So having shorter lead time is obviously just the inventory risk, but having longer is basically setting your shop for failure. So it lets you check all those things and make sure your recs are generated correctly. You are able to update the ERP system. Or if you don't want to do it in ERP, just run FactoryTwin and it'll run with the demonstrated lead time rather than the system lead time. Then you have spend analytics. You can look at any part. What is my spend analytic in the past? You can again slice and dice that data. What is my unit cost variation over time for every part, every customer? What is my purchase part variance? People are always looking for that. Year over year, you can calculate that. So that's all in the supplier performance. Then you can do supplier planning, and I'm going to go to the one chart which is the most important here, and that is material shortage analysis. Try doing that. Plan for every part that you buy. Offline, it takes forever. Now here, you can select any part you have ever bought, and you have demand in the future. It tells you what is in your inventory right now, what is your consumption point, and when is the next PO coming in. And it also tells you this dotted line, if you were to place a PO today for some reason, this is the lead time it'll take to deliver that part. So I'm going to pick another part here. So in this case, I have inventory. This has basically in the system 0 lead time. So that means you got to go fix the system. Another part I picked, there's a purchase order arriving today, which has 60 units. In my inventory, I have 38 units. So I'm going to end up with 98 units. If I place any order today, it'll come here based on the lead time. But here is another PO coming. And here are my consumption points. A lot of consumption in January 2026, and so on. And you can see until now, until January 2026, I'm okay, but I need to place a PO to be handled with this big consumption point. So I'll first go into the demand profile and understand this is real. And then based on that, I know that my lead time is here, which is about 50 days. So before January, I need to place a PO. And by the way, all that is listed below in a lead time orders as well. So you can go, what are my future orders that I need to place? Purchase order placement alerts for next 3 months also show up. So you can do supplier planning, you can do supplier performance, then you can jump into your inventory data. It's also connected. You can see bucketized by details, work in progress, raw material. I mean, some people, companies that I work with, spend a lot of time just doing their monthly or bi-weekly inventory meeting. And you can see it's all automated here. You can see how they're bucketized, how it's aged. You can, let's say my focus is on raw material. I can see this is my aging. I do have a bunch of material, about 1.5 million, which is more than 3 months old, 3 years old. I need to worry about it. Similar with activity. I have a bunch of raw material for which there is no activity. So activity means I don't have any need for it in the foreseeable future. And I want to know more about it, so I can even go down and look at, for each raw material, I can select inventory type as raw material, apply, and it'll tell me by part number, age groups, add filter, inventory type, raw material, apply, and then it'll tell you for raw material part numbers. I have one part in the inventory which has been sitting there for a while, and it has no demand whatsoever. Some have partial demand, some are fully consumed in the future. So you can start to look at by part number. And by the way, every visual I showed you so far can be converted into a table. So although it's only showing the 10 top parts, you can also see all the other parts and what is their activity and who the customer is and who the supplier is, etc. So this way you can handle the week 3 part of inventory risk, while week 2 activity on supplier performance risk and supplier planning and shop resource bottlenecks are being continuing. And then you can see week 4 what the financial impact of all that is. And that you can see in terms of what my budget for revenue is, what I think I'm going to do by customer supply, what is my profitability, what is my contribution margin. So this is basically all, that's how S&OP process works. So see, as simple as once it's introduced, the site you want to do the S&OP ad, you just click on the view button and you can start running your week by week S&OP activity. No need to download data, connect data. All that has been done in the implementation phase. The subject matter experts' tribal knowledge has been captured. All the live data sources have been connected, whether they are IT systems, OT systems, or stationary Excel sheets, etc. So this is what S&OP process is all about, and it's and how to use it in an efficient manner without having to spend time on it. And as I mentioned earlier, our customers that are using it are showing benefits in double digits, sometimes in 20% plus. So now I'm going to go to the next one and talk a little bit about AI. So what you just saw, you didn't realize already had AI in it. And that's the analytical AI piece. So from a user perspective, we think of AI as of three flavors. One is generative AI, which is ChatGPT type stuff that you see all the time. That's what the buzz is. It's good for ideation, not for decision. We don't think it's accurate. I think it hallucinates a lot. It requires a lot of training. If you just let a Claude or a ChatGPT run amok with your data, people who are doing it, the success rate is 5 to 10%. 90% projects fail if you apply generative AI straight to your data, which is not structured, is not contextualized, there's no ontology, no infrastructure in place. Then there's analytical AI, which is already included in what I showed you. It includes advanced statistics and machine learning to do certain calculations, like running simulations quickly for a shop, which I showed you with hundreds of parts, dozens of suppliers. You can run those simulations in a matter of seconds. That's already included. But now I'm going to show you what is the new buzzword, and that is agentic AI. So agentic AI is a combination of analytical AI and generative AI, and you train the agent on your specific set of data to reduce hallucination and increase reliability. So agentic AI for us right now is in beta phase, and we are happy to discuss this with people and who want to participate, be a beta partners on that. But the reason it works is because the data is already contextualized and structured and has the basic interrelationships established as part of digital twin implementation. So once you have S&OP implemented, you can run agentic AI and get some additional benefits. So I'm going to show you what those additional benefits are by running some more of them. So now I'm going to go into our agent. So Agent Kate is actually running on data, the backend data of FactoryTwin and, for example, S&OP module that I just showed you. So what is the advantage of having agentic? Well, one advantage is that when you're running, as I showed you the demo, you pretty much need to be an expert at buying function or planning function, or at least you need to know which button to click to get what information. If I'm looking at bottlenecks, I need to go look at my resource heat map. I want to look at what is driving that. Then I know how to run the scenarios because I have that knowledge. Now, if I'm the CEO of a company, I'm not an expert, and I want to learn the same things, I can run agent for that. So, for example, the same kind of things that I showed you in the S&OP demo, I can do it by running agent. So let's say I want to ask the question, which I got by clicking a few buttons. Let's say which Minnesota resource group, again, resource group is a technical term, which means both stations and operators. Which resource groups are bottlenecks, right? That was the question that heat map was responding to. And I'm going to ask it in natural language, but I need to specify when, right? So let's say in May of 2026, and the reason I picked it is because I showed you there was a big bottleneck for EDM, right? So which Minnesota resource groups are bottleneck? And I click it, and so the agent gets into its loop thinking mode and starts to look at all the data and sees what is the right data I need to look at. I need to focus on May. So when I look at all the resource groups available, and you can see the way we have made this agent is it's transparent on how it's thinking and what database it's accessing. So you can see what it did after the fact. So here you go. Here's the answer. These are the resources in May of 2026, which are bottlenecks. So it shows, EDM labor was shown at 188%, CNC labor is, so in that specific month, we had all those different resources that were the bottlenecks, right? It also points out a machine, not just a labor group, but a machine which it calls not over capacity, but constrained, because it has the knowledge that anything above 80% utilization is something you need to worry about. So in addition to 5 resources which are overcapacitated, there's one resource which is on the borderline. So you need to worry about all of those resources, right? So like I did in the tool, I said, okay, if that is the problem in May, and EDM resource is a problem, which part is consuming that resource, right? And when I showed you in the S&OP tool, I went inside and if you remember, I went in and I went into, if you go to week 2 and I scrolled down and I clicked another button and I said, okay, if I do EDM labor, what is causing my most, and it showed me these are the parts which are causing the bottleneck. So I go in here and ask the same question here. Now I'm not clicking anything. I'm going to just say, which part is consuming, I misspelled, but I don't think it matters, consuming the Minneapolis EDM labor the most and if we are still going to stick to 2026 and see what it says. And then we can go double check if that's the correct answer. So again, it's going into this entire data set, which has got millions of fields, and it's finding the right data to see where the constraint is, where it's in May, and which part is causing it. And it's gonna, once it gets to the right table and it joins the right data set, then it executes Python to actually calculate what that is. So let's see what it tells me. Still running, it says CFCK is the part with 76.8% consumption. Let's check if agent is right. I'm going to go to my data set and I'm going to go to operator utilization. In May, here you go. CFCK 76.8%. So agent is doing a good job here, right? Calculating all these things. Now I'm going to write a very open-ended question. Let's say you are a supply chain manager or a buyer in a factory. One of the things your leadership is always telling you is, hey, your suppliers are not performing on time. And by the way, they're expensive. Why can't you do some resourcing or come up with a strategy on what part needs to resource from one supplier to the other so I can get not just cost reduction, but also better delivery performance? And to do that exercise, if you've been in supply chain, as I've been in, many times, it takes weeks. And you're trying to get it for the entire factory. Well, let's ask Agent Kate the same question. And I'm going to ask it in a very open-ended manner. What are my, let's say, strategic sourcing options? Because that's what it is, right? I want to do some strategic sourcing and move from one supplier to the other. So I'm going to say, what are my strategic sourcing options? Let's see what it gives. What I expect it to do is to go to the database, identify the parts for which suppliers have poor OTD performance, on-time delivery performance, and have price escalation. And then find suppliers where you have better on-time delivery performance, even for different parts. But if we have ordered the same part from that alternate supplier, whether there's a cost benefit. So it's going to run that, it's going to go to the data, it's going to execute the Python, and it'll give me the result as to what that is. And it's going to visualize the result. Maybe, I don't know, it's going to be a table or it's going to be a graph. So give it a few seconds and notice I didn't have to go click on anything. If you were to do that strategic resourcing strategies for a year, like I said, it takes weeks, even in the S&OP module that I just showed you, it might take you, 10 or 20 minutes because you'll have to go and click on multiple places to come up. So it says, here's a table of 20 parts showing key metrics such as current and alternate suppliers, prices, volumes, cost savings, etc. So let's see what it shows. It's going to probably show the visualization and data. You can look at the thinking, which has gone through. There we go. So let's see what it came up with. So it tells you list of part numbers, right? What is the quantity purchased from that for that part number typically? Who's the current supplier? What is the current supplier's on-time delivery? It's 70%, let's say in this case, right? And then here's a best alternative supplier whose on-time delivery at the current rate is about 90%, and whose cost and the pricing is given so that you're getting a 360, whatever the total cost saving for the overall purchase, as well as improvement in OTD. So you can go, the top 10 part numbers are listed here with their, what is their current supplier, what's the current on-time delivery, what's the current cost, and what's the future expected. But this is super powerful, right? To do these kind of things with AI. So I think I've used up about 50 minutes plus, so I'm going to stop right here and maybe just share just the last slide and invite questions from the audience. Let's see, here's my presentation mode. Okay, so, and if you want some additional resources, there's stuff that we publish with Society of Manufacturing Engineering, and there's some internal resources. Happy to answer any questions at this point.
All right. First of all, thank you so much, Vivek. What a fantastic presentation. And for those of us that have not been exposed to this detail of what's possible, this was very eye-opening and great awareness for me, at least. So let me open it up. If anybody on the call wants to ask a question, you can type it in the chat, or I believe you can unmute yourself and ask it. Let's see who has the courage.
Here you go. You got a hand up.
Yeah. I saw a hand up from Rajiv.
Yeah,
Can you
just,
unmute? There you go.
There's two questions for you. One is, this solution do you have, like, typically, what would be the profile of the organization that would, whether it's like, I mean, in terms of scale or type of industry, if you think that actually a better fit. And the other is, so, I mean, you clearly emphasized a lot of the data aspect of it, from in terms of readiness. What do you think are the conditions with AI readiness, particularly from the data governance aspect of it? If you could answer those two questions. Thank you.
Sure. So the first question about what is the scale of a manufacturing company that is best suited for this? So I think there is a lower limit, but not an upper limit. And the reason is if you're a mom and pop shop with 5 machines, you don't need computers to make you plan. So generally, if you look at from our experience, our customers have ranged from about $20 million revenue to multi-billion-dollar revenue. So our smallest shop currently using this is in Savannah, Georgia, with about 30 or so operators, and they are seeing the benefits of S&OP right now. And the return on investment actually worked for them because they were tripling in volume in the next 2 years, and they were able to do all this planning for CapEx and employee requirements, et cetera, very, very quickly. And they do it repeatedly, monthly S&OP review. We have another customer in Michigan with $150 million revenue with 3 sites. That's the molar space video I was referring to earlier. And so with 3 sites, $150 million revenue works beautifully. They have shown 16% improvement in throughput without any resources. So that's a huge win, and they have gone public in talking about that. Our biggest customers have been, we have worked with Lockheed Martin. We are working with a customer currently, Karman Space and Defense, which is a $750 million company. We are working with Pratt & Whitney, which is a multi-billion-dollar company. But again, when we look at large companies, they are basically groups of smaller factories, right? There's no $100 billion factory, right? So typically, unless you have a mega factory like that, typically most companies, even if it's a $500 million, billion-dollar company, they'll have 20 sites or 10 sites, which are manageable. So when it comes to scale, it works at any scale. The time it takes to simulate the results, the scenario analysis just increases. What I showed you was typically a $100 million factory. As you go bigger and bigger, it'll just take longer to run. Because just from the computer resource perspective, you can run on Google Cloud or something and it can be still faster, but that's the resource consumption is the only issue, nothing else. Now, the second question is data readiness perspective. So there, we are presenting, I'll invite you to a presentation we're actually doing at University of Minnesota Technological Leadership Institute next week, where it's all about that. It's about how to get data in shape for AI to be used. And there's a lot of nuances and details. So if you had done S&OP before and you saw the demo today, you saw the nuances and details that are required for it to work. Similarly, when you go to fully AI applications, there are a bunch of things. And what we find is where we spend most of the time. So because we started working, our company is 10 years old. We started working on AI maybe 3.5 years ago with a National Science Foundation grant. And what we have learned is that if you think about the cake of using AI that Jan LeCun, one of the godfathers of AI, always talks about, that the cake itself is self-supervised learning, and then the cream on top is supervised learning, and the cherry on top is reinforcement learning. Well, when it comes to agentic for a specific function like manufacturing, it's actually reversed. The cream and the cherry are the biggest effort taking, because LLM, you're just taking from what is already a self-supervised learning output. And then you're putting on it your data-specific learning. And that's what your question is about. How do you make sure that supervised learning and reinforcement learning works well with any of these agentic applications? And that requires proper ontological infrastructure. By ontology, I mean not just uniform naming system, but also interrelationship between various variables that go into running this. I'm not going to get into the governance issues that relate to cybersecurity and so on. That's obviously something that IT departments worry about. We work with them when we go to the customer, but the time we spend in applying AI to a customer data is really about preparing the data for AI through making sure that there's uniform naming system, there is a data, the schema which is behind FactoryTwin accounts for all that interrelationships of variables. There's no duplication, there's no confusion. When you say purchase parts, this is what you mean. When you say batch versus lot, this is what it means. And so that's what takes a lot of time, contextualizing the data and making sure that the common uses of words don't confuse the agent. Like I just mentioned, batch versus lot. A lot of manufacturing people use them interchangeably. They're completely different things. Batch is a number of pieces you can run at a given operations in parallel, whereas the lot is the quantity on your job. So the ratio of lot to batch size actually determines how many times you'll need to do the setups or changeovers. So these are the technical details we worry about when we try to get the customer data ready for AI. I hope that answers the question. If you have further discussion, more detail, happy to engage offline. Any other questions?
Thanks, Vivek.
Thanks, sir.
Any other questions? We're coming up on the edge of the time, but I'm going to ask kind of a what I call a crawl, walk, run process. Where what we saw in a demo is kind of all this data is already in there. Is there a process or a method where you kind of get companies started and we can get what we can get and we continue to improve and add functions? Maybe we don't have all of the data and the dollars and the different things. Maybe we don't have that all at the start, but then those can be improvement steps that we take. Is that a process?
Yes. So one thing I'll refer you to is this link. So there are two articles we have recently published, one through MPMA magazine and one in the Society of Manufacturing Engineering January issue, where we talk about how to get ready for digital and AI and how to get your data ready. So that goes through step by step. I mean, I can just elaborate quickly. The first thing is data collection has to be standardized. If your operators are not scanning at operational level, when they start an operation, when they finish that operation, you need to enforce that, right? If you don't have standard process of collecting data, how do you trust it? Now, if you've done it for a long time, I can look at your past jobs. The software can look at your past jobs and come up with statistically what is the approximately the right actual time for that operation. But you need to enforce that standardization in your shop. Similarly, now you don't need actuals every single time. You can run S&OP just with your standard times in your part master and ERP. So there are ways to get around if your data is imperfect, and there are ways to actually improve data. That's why that step of data diagnostics is so important. So what we do is, here are basically the steps which are here. Do a workshop internally. See where the data, operational data resides. What are the places where the data resides, right? You may not be able to yourself do the ETL and doing the integration and a transformation of all that data in a schema that makes sense. So, but if you can do that, or you can bring somebody like us to do that for you, then you can start looking at what the gaps and inconsistencies in data are and how they need to be fixed. And given the business problem you're trying to solve, the automated data diagnostics tool actually tells you what needs to be fixed. Standard times missing, purchase order doesn't have the quantity it needs to have. And so you can real time keep checking that data as it gets improved. And with this rigor of following step 1, 2, 3, you start to get ready. So if you want to say, what is crawl, walk, run? Crawl is first understanding all the data that you have standard processes for collecting that data, and you know where that data resides, and that you have at least the confidence that people are putting that data, and if there's some standardization that needs to be improved, that needs to be in place. Then you go to walk, which is when you integrate all this data and look at the diagnostics of that data. And run is when it's all running, then you can start moving and looking at the results. So briefly, in the time allowed, that's how I would present, but I can talk more detail. Every shop is different. So, we present these modules as off the shelf, but almost always it's 80 to 90% off the shelf, 10 to 20% customization, because every shop is different. Even two machine shops doing very similar parts will have a slightly different way of collecting their data, a slightly different way of running their routings, etc. So hope that answers your question, John.
Yeah. Yes. Thank you very much. And I love the resources to help us get started and help us see what we need. I talk a lot about just awareness and visibility to things, right? If you've got somebody with a spreadsheet and somebody else in the system, and somebody maybe scanning, somebody not scanning, being able to tell that without spending, 40 hours a week trying to find that problem is a great advance by itself.
Yeah. So collecting data gets improved also through using a tool like this.
Right. Excellent.
Great. Very good.
All right. Well, we've reached the end of our session. Thank you so much, Vivek. That was a fantastic, eye-opening session, and gave us a lot. I hope gave everybody a lot to think about. Certainly gave me a lot to think about. And we appreciate everybody joining us. We will try and get this recording condensed and put on the website. So keep your eyes on twincities.ascm.org. And we will try and have a link there, as well as probably on our YouTube channel. So thank you, everybody. Thank you, Vivek. Thanks for joining, and have a great rest of the week.